How does the network arrive at the actual new software that once people have expressed their requirements, and then you find the points of agreement? Where do the requirements overlap? Where do they agree? So then what's the next step? Once you find those specifications, how do we get to the how of the software?
Starting with directions analogy, one says, I want to go to a supermarket, and the other says, I want to go to a restaurant. They feed this to the computer. So Google Maps prepares a route that goes to a supermarket and to a restaurant. And then the self-driving car executes this route. So indeed, after people say what they have to say, we automatically calculate the agreement. We get some kind of specification. And we automatically run this specification. So that's yet another point. The specification is executable indeed, automatically.
The specification is itself already executable. It doesn't need to be translated to Python or C or anything like that.
That's right. Well, there should be some program that takes the specification and runs it. So you can look at it implicitly as translating it to machine code. But just like, Java, Python that you mentioned, they are also not compiled languages. There's some interpreter that runs it. Same here. There will be interpreter that runs the Tau language.
Excellent.
By pushing the Google Maps metaphor, this is exactly what AI does. You really say, I want to go from A to B, or even take a robot or Google Maps, whatever, and that's all you have to say. Then the system finds the execution path. This is the path, and this path, of course, there are many, possibly infinite paths, different programs that execute your desire, your specification. And so you may give references. You can say, well, I want to have the shortest one, or the fastest one, or the cheaper one in terms of fuel they need to use, or whatever. So you have a sort of, among all the possible realization of this specification, because of course there are many, there will be reason to prefer some over others. So this is a typical AI problem, which in the naive way is implemented as a search problem. Things in terms of a robot, I start at a certain position. I know I have to go there. First of all, I can have some heuristics. I can have some way to try first. So I know if I have to go to the city center or to the supermarket, I know that it's in that direction because you see the tower. However, well, I go in that direction, but then I hit against the wall. Maybe this is not really smart. So, well, I backtrack and I try to go slightly on the left. And then I keep going, trying to go in that direction. So I have some driving force, which is the heuristics. I search for the solution by potentially failing and backtracking. And then eventually I find the goal. That's how Google Maps finds your path, the best one, the cheaper one, whatever, using these kind of principles. Now, what is also quite special in the technology employed by Tau, which is fully an idea of Ohad, is that we don't rely these algorithms on search. We don't base these algorithms on search, but we use them based on a different kind of technology, which is Boolean algebras and automata. So in this sense, we avoid also, hopefully, somehow, in most of the cases, the hopefully means you cannot guarantee that the solution will be found always in the fastest possible way, but you can approximate the optimality by minimizing the time that you waste by doing wrong choices. And then you try to find the best program, the best implementation of your specification in a reasonable amount of time.